this lesson, we're going to look at adding and subtracting radicals. And radicals include square roots, but they also include cube roots, fourth roots, fifth roots. We're not going to go quite that high in this lesson, but we are going to look at cube roots. We're also going to look at simplifying radicals when there are variables involved. What to do when you've got an x or an a or a b or whatever underneath your radical sign or your square root sign. So just a quick review of how to simplify radicals, and first by thinking, what does it mean to take a square root? So we know that a square root of 16, because 16 is 4 times 4, the square root of 16 is 4. In other words, the square root is asking what number times itself will give me the number under the radical. Or to simplify, a number multiplied by itself is simplified by coming out of the radical. So 4 times 4 is 16, square root of 16 is 4. If we're going to think in a couple more numbers, you might go, okay, well, 1 times 1 is 1, so the square root of 1 is also 1. And 2 times 2 is 4, so the square root of 4 is 2. 3 times 3 is 9, so the square root of 9 is 3. And you can keep listing down. We're actually going to use this list in order to help us simplify our radicals. So, example number 1, we want to simplify the square root of 20. And the book way, or the way that it's often taught, is to find all your prime factor pairs by just factoring the square root of 20. So 20 would be equal to, well, let's see, factors 2 times 10, and factors of 10, that would be 2 times 5. And there I've got a pair of factors. And that pair of factors is going to come outside my square root. So on the other side, I'm going to have the 2, only one of them, outside the square root. And anything that doesn't have a pair is left inside. Square root of 5 is inside. So that's one way of doing it. When your numbers get bigger, it gets harder to find the prime factors. It takes more time to find the prime factors. So we're actually going to do it a different way. If you like the prime factor method, you are free to use that. But we're going to actually use the perfect square factors method. And in order to do that, we're going to write out the rest of our perfect square factors. So 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9, 81, 10 times 10, 100, 11 times 11, 121, 12 times 12, 144. You don't usually need to go higher than that, but you could find them on your calculator if you need to. You should memorize this list of perfect square factors because it's going to come in useful. If you need to write it out a couple times in order to remember it, that's fine. And after that, you should actually have it just kind of in your head, knowing what the perfect squares are and what their square roots are. So, to find the perfect square factor way of finding the square root of something, I start out with my number. In this case, it's the number 20, and I say, okay, looking at my squares, 20 is between 16 and 25. So I'm going to see, starting here, working my way downward, if any of these are factors of 20. So 16, no, not a factor of 20. 9, no, not a factor of 20. 4, yes, a factor of 20. So I'm going to rewrite this as square root of 20 is actually going to be the square root of 4 is a factor of 20. And if you need to do that on your calculator, you can. 4 times 5. And then looking at this, I go, okay, the square root of 4 is 2, so this is going to be 2 square root of 5. So again, you can do it the perfect square factor way. You can do it with the prime factor pairs. Either way, you should get the same answer. So let's take a look at a few examples. Example number 2. 5 times the square root of 112. So the number on the outside is just going to hang along for the ride, and any factors that come outside, we're going to multiply with the 5. So 112, I'm going to look up here and say, well, 112 is more than 100, but less than 121. That would come right in here. And now I start looking for perfect square factors, working my way down the list. Again, if you need to pull out your calculator and try them, go ahead. But I can tell you right away, 100 is not a factor of 112, 81, not a factor of 112, 64, not a factor of 112. And if you keep working your way down the list, dividing, 112 divided by 49, 112 divided by 36, 112 divided by 25, the first perfect square factor you find is 16. So this is going to be square root of 16 times, and if you do it in your calculator, times 7. Okay, square root of 16 times 7, and I know square root of 16 is 4, so this is going to be then 5 times 4 when it comes outside, times the square root of 7. 5 times 4 is 20, so this is going to be 20 root 7. That would be my final answer. All right, let's try another one. This time we're looking at 45, A5, B6. So 45, I'm just thinking 45 is going to fit in right here between 36 and 49. So checking for perfect square factors, not divisible by 36, not divisible by 25, not divisible by 16, not divisible, oh, it is divisible by 9. So this is going to be square root of 9 times 5 is 45. And then this is A times A times A times A times A, 5 of them. And B times B times B times B times B times B, 6 of them. And for my first part, I'm going to simplify same as I have been. Square root of 9, square root of 9 is 3. So 3 comes outside and 5 is going to be left inside. And here I've got, again, this time I will think about pairs. So I've got a pair of A's, that's going to be an A outside. Another pair of A's, going to have an A outside. Pair of B's, B outside, a pair of B's, another B outside, a pair of B's, another B outside, and what I'm left with inside is the 5, and this little lonely A that had no pair. Simplify that down on the outside to be 3 times A squared, B cubed, and 1 left inside. Now, if you want to write this out every time and look for the pairs, that is A-okay with me. The other way that I think of this is as a square root, I try to divide the exponent by 2. So 5 divided by 2 is 2.5, so I got 2 A's that come out, and the 0.5 represents the 1 A that stays inside. 6 divided by 2 is 3. Since it divides equally, there's no 6's left inside, and there are 3 of them left, or that come outside. So if you want to do it that way, 5 divided by 2, 6 divided by 2, because it's a square root, if we have cubes, we're going to do divided by 3, then that is also a possibility. You just have to think more along the lines of what remainder is left when I divide 5. Well, I can divide 5 by 2, and I get 2 remainder 1, instead of thinking in terms of decimals. So whichever way you like, you can skip right to the end if you don't want to have to write everything out. It just depends on you. All right, another example. I've got 3 cube root of 54. Now, cube root means instead of being able to use my perfect square factors, I'm going to have perfect cube factors. So perfect cube factors means I'm going to take, whoops, didn't want to erase quite that many. I'm going to take my perfect squares and multiply them by themselves one more time. So 1 times 1 is 1 times 1 is still 1. 2 times 2 is 4 times 2 is 8. 3 times 3 is 9 times 3 is 27. 4 times 4 is 16 times 4 is 64. Now I can keep going, but I've already found 54 is less than 64. So I'm actually going to stop there and say, okay, my 54, it fits in right here. So is 27 a factor of 54? Type it into your calculator. It turns out that it is. So what I've got is here 3 times the cube root of 27 times 2. Now the cube root of 27 is going to be 3. That's what gets to come outside. And I've got x times x times x times y. So this time I'm looking for what times itself times itself. I need 3 of them together in order to get them outside. So 27 is 3 times 3 times 3. That's what gets it the power to come outside. So I've got this first 3 outside already, times 27. The cube root of 27 is another 3. So that's going to come outside. And I've got 3 x's, 3 times 3 times 3. One set means 1x comes outside. And what I've got left inside is the 2 and the y that have no friends. So I've got cube root of 2y. Just simplify that a little bit. 3 times 3 is 9. X cube root of 2y. Now do be careful how you write this. You don't want it to look like 9 times x cubed square root 2y. You want to make sure that it's obvious that 3 goes with the radical sign and not with your x. That is a big no-no. We do not want that because that does not mean the same thing. That's a square root. This is a cube root. This is an x cubed. This is just an x. but this would be what we're looking for as our final answer. And again, thinking about not having to write everything out, if I think about, okay, cube root, I'm going to divide by 3, divide my exponent by 3. 3 divided by 3 means I get 1x outside, and there's only 1 y here. So 1 divided by 3 is 0, remainder 1 means there's no y's that get to come outside. So again, it depends on you which way you like better, shortcut, long cut, either way will get you to the answer. So that is simplifying radicals, and now we're going to look at how to combine like terms. So when we've got just regular numbers, 1 plus 5 plus 7, that's easy. I can go 1 plus 5 is 6 plus 7 is 13. Doesn't quite work the same way when I have the radical sign. You might think, oh, okay, root 1 plus root 5 plus root 7, is that root 13? If you type root 13 into your calculator, you get 3.60555 ... doesn't end. Okay? If I type in each of these, root 1 plus root 5 plus root 7, I get 5.88181. Are these two decimals equal? No. So, in other words, that does not work. I cannot add the numbers under my radicals to get a new radical that would be my answer. Doesn't work that way. Rule does not function. So, the only thing that I can do is maybe simplify some of these radicals, and that's it. There's no more simpler to get. So, root 1 is just 1. Root 5 can't simplify, root 7 can't simplify, and that would be your final answer. The only way that I can add these together is if I have like radicals. So think like terms have the same variables, like radicals have to have the same roots. So we still want to be combining like terms. So look at the next example. I have a plus 5a plus 7a, and you guys all know this is an invisible 1 here. That is just 13a. No problem. Like terms, add them together. They all have a's. We only get one a at the end. It's all good. Same thing happens when I have like radicals. So I've got root 5 plus 5 root 5 plus 7 root 5. Every single one has a root 5, just like every single one here has an a. If that's the case, then I can just add their coefficients just like I did with the a. So these are like radicals, and I can go 1 root 5 plus 5 root 5 plus 7 root 5 is going to be 13 root 5. Now I don't go 5 plus 5 plus 5 underneath, just like I don't have a plus a gives me more a's. That would be weird. I just end up with a at the end here, or root 5 at the end here, same idea. Now, if I look down at the next example, I've got a plus 5b plus 7a, and you guys all know what to do with this. Again, 1a and 7a, those are my like terms, gives me 8 a's. And the 5b's, they just stay 5b's. They have no friends, that's it. Can't combine them, they're stuck, that's the answer. Same idea when I've got like radicals. I've got root a here, root 8 here, cube root of 8, not the same because it's got a cube, and 7 square root of 8. So I can combine root 8 and 7 root 8 to get me 8 root 8. And my 5 cube root of 8, he just hangs around. Now, the one difference with simplifying or with combining, adding and subtracting radicals is that sometimes there's some simplifying that needs to go along with that. So root 8, I need to be able to simplify, and if you look at your perfect square factors, 8 is going to be root 4 times 2. 4 is a perfect square. And 5 times cube root of, well actually cube root of 8, 8 is a perfect cube itself. So I don't need to rewrite this, it's just going to be equal to 2. Cube root of 8 is 2, and when I have no times anythings underneath, I have a perfect cube, the radical is just going to disappear altogether. So the first one is going to be end up 8 times root 4 is 2, root 2, and this is going to be 5 times cube root of 8 is also happens to be 2, and bring it up here because I ran out of space. 8 times 2 is 16, root 2, and 5 times 2 is 10. And that's it. Can't combine them because this one has a root 2, this one does not have a root 2. They are not like terms. That's your final answer. Stop there. Just like 8a and 5b was my final answer. Couldn't do any more with that. Okay, few more examples. Let's see where we go with more terms to work with. So I want to add or subtract actually 4 root 108 x squared minus root 192 x squared. Sorry, this should be underneath the root. Let's see if I can fix that. All right, there we go. That looks a little better. So we want to be able to simplify this, and again, to do that, we're going to need our perfect square factors. I'm going to list those down the side again. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Again, if you have this memorized, then you don't have to actually write them down, but I find it helpful to keep track of them by writing them a few times. 100, 121, 144, and we could keep going if we need to. So, for example, 4 times square root of 108. 108 is going to be right in here. And let's see if we can find some factors. So, 100 not a factor, 81 not a factor, 64 not a factor, 49 not a factor, 36 possibly. Let's try that on our calculator. 108 over 36. Yes, it is. It is 3. So I've got 4 then, 4 times the square root of 36 times 3. And this is x times x is going to give me a pair of x's. And looking at 192, if I kept my perfect squares going a little higher, I would get 192 somewhere up here, but I'm just going to stick 192 right here at the end. I don't think I need to go any higher. The only next one would be 169, which is 13 squared, and 14 squared is already higher than I need to go. So 192 is going to fit to 144, not a factor, 121, not a factor, 100, not a factor. Let's see if 81 might be a factor. Nope. 64, not a factor. Oh, it is. 192 is 64 times 3. So if you're not sure, again, keep typing into your calculator until you find one that works. So this is going to be 64 times 3, and again, x and x. So pull some stuff out. 36 was square root of 6, so this is going to be 4 times 6 root. Oh, hang on, I got a pair of x's. That's going to pull out an x. Then I want my root, and I only have left in here is 3 minus 8 root. Oh, again, I have a pair of x's going to come out. 8x root 3. I'm going to simplify this to be 24x root 3 minus 8x root 3. And what do you know? I've got like terms. So these are like terms because they both have an x and they both have the same radical. So in that case, again, we can just combine their coefficients. So 24 minus 8 is 16. And then the x and the root 3, they are just happy to be along for the ride. One more example before it's your turn to try it. And this time again, we're working with cubes. So I'm going to complete this chart by adding on my perfect cubes, and I'm going to stop whenever I get a number greater than 54 because I don't need more than that. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, and 4 times 4 times 4 is 64. Stop there. Simplifying the first term. 16 fits right between 27 and 8, and 8 is a factor of 16. So I'm going to write this as 3 cube root of 8 times 2 plus 4 cube root of 24, again, fits between 27 and 8. This is going to be 8 times 3 minus 5 times the cube root of 54 is right between 64 and 27, and it is 27 times 2. Again, if you need help, use your calculator to find the factors. That is totally fine. So I'm going to pull out, this is going to be 3 times cube root of 8 is 2, and I'm left inside with a cube root of 2, plus 4 times cube root of 8 is 2, left inside cube root of 3, minus 5 times cube root of 27 is 3, cube root of 2. Combine those, this is 6 cube root 2 plus 8 cube root 3 minus 15 cube root 2. And now I look to see if I can combine any like terms. So in this case, I have a cube root of 2 here and a cube root of 2 here, so I can combine those. 6 minus 15 would be negative 9 cube root of 2. And the 8 cube root of 3, the cube root of 3 is a not like term, so he just stays the way he is, cube root of 3. And that's it. You found the answer. So now there are 2 more questions for you to try. So pause your video now, try them on your own, then come back and check your answer. Pause. All right, and here we go with your answers. So the cube root that fits into 320 is 64, so it's 64 times 5. And an x cubed cube rooted brings me 1x outside. 64 cube rooted gives me 4, so 3 times 4 is 12. And I'm left inside with a 5 and a y squared. And the last one, 486 is 81 times 6. Took me a while to find that, don't know about you. And 294 is 49 times 6. Again, took me a while to find that, but hopefully you got there faster than me. And so square root of 81 is 9, square root of 49 is 7. Combine your like terms and you're done. Good luck with your homework and your mastery check.